Today we are going to solve one interesting interview problem where we are given an array which is almost sorted, but we have to find out positions in the array where it is not sorted, and if we sort that subarray, the whole or complete array is sorted. So let's take a look to an example over here. So this is an array 1 2 3 6 5 4 7 8, and if you see, the array is not sorted from this position to this position, and if we sort this position, and it will be sorted. So for example, 654 will become 4 5 6 7 and 8. So a basic algorithm which we can see, for example, a sorted array which is in ascending order, it has an interesting property that when we are moving from left to right, every element should be greater than the previous element. So for example, 2 is greater than 1, so we are good. 3 is greater than 2, we are good. 6 is greater than 3, so we are good. But 5 is less than 6, so we know here at this position this property is broken, so we will notice this index over here. And same way, we know for a sorted array in ascending order, when we move from right to left, it should be always greater than the previous element. So for example, 8 is greater than 7, 7 is greater than 4, but here 4 is not greater than 5, so we'll note down this index. And if we see, it's a 0 1 2 3 4 5 6 7, so our answer would be 3 5. Very simple, right? Okay, but there is a catch. So let's see another example. So I have an array 1 10 9 3 0 5 4 8, and if we do with the previous approach, so 10 is greater than 1, so we are all right, but 9 is not greater than 10, so we'll note down this index. And same way we'll proceed from right hand side. So 8 is greater than 4, we are good, but 4 is not greater than 5, so we'll note down this index. So basically we have index 1 2 3 4 5 6, so we'll give answer as 1 to 6. And let's sort this array, so it becomes 0 3 4 5 9, right, and 10. And we'll put the previous element here and the next element over here. So is it sorted? So we can clearly see this is not sorted. So the catch over here is you need to basically find a minimum element in the subarray, and you have to move that element uh, in a proper position. So for example, here this is 0, so we need to move 0 before the 1, and the maximum element is 10, and so we need to move it to proper right place, so it will become at the end somewhere. Okay, then this array will be sorted, so it will become 0 1 3 4 5 8 9 10. So our actual answer would be from position 0 to the end position, which is basically 7, so it should give us answer 0 to 7. We solve this problem. So I think we can think of a easy approach where we can sort this array first, store it in another array, and compare each index and try to find out where they are not matching, and we can create the answer from there. So for example, if I sort this array uh, and store in another array, it will become 1 2 3 4 5 6 7 and 8, and then I will keep on matching index by index. So this is matching, all right, this is matching, all right, this is matching, all right. So here it is not matching, so we'll say the left index is equal to 3 0 1 2 3, and we'll keep on matching. Okay, 5 is matching, 4 is not matching, so right becomes index number 1 2 3 4 5 6, and others are matching, and this way we'll find the answer is 3 comma 6. If we see, the time complexity is like, because we are sorting this array to another array here, so it will be order of n log n, and the space complexity would be order of n, because we need another array to store the sorted data for that array. It seems to be pretty simple. Another approach where we will use the intrinsic property of an sorted array, and we'll try to see if we can reduce the space and time complexities. So for example, I have this array at the top where we need to find out the indices. If we sort between those indices all the elements, the complete array becomes a sorted array. So let's see first what if we sort the complete array. The answer would be like 0 1 3 4 5 8 9 10. And if you see, the property which I am talking about is very simple, and we can use that property to solve this answer. So whenever we are moving from left to right in an ascending order sorted array, the current element will always be the greater element. So for example, if I start from zeroth element, so zeroth element will be the max seen so far. And if I move to index 1, so this should be the max seen so far. So we can clearly see 1 is greater than 0, so it's the max seen so far. We keep on going ahead, we see 3, and 3 should be max seen so far. So now max, we will update the max seen so far, it will become 3, and we know that 3 is greater than 0 and 1. Same way, if we go to 4, we know that max seen so far should be this array at index 3 when we are at index 3. So at each index, the element should be maximum till now whatever we have seen. And if we keep on doing this, so 5 is, if we are at index this of this element, so value 5 is currently the max seen so far from all the previous element. Same way, 8 is when we are at position this, 8 is the max seen so far. When we are position 9, it is max seen so far. When we are at position 10, we are at, it is max seen so far. And same is true when we move from right to left. Same sort of property is true when we move from right to left. In that case, each index when we are visiting from right to left should be the minimum from the all the values which we have seen so far. So at this position we have not seen any value, so 10 is the minimum so far. When we move at this position, so 9 is minimum so far. At this position, 8 is the minimum value so far. Same way, if we move ahead, 5 is minimum so far, 4 3 1 0 is minimum so far. So we will use these two properties to find out the out of order indexes. Okay, so let's take an example and see how we find left and right indexes of the subarray which needs to be sorted to make this complete array as sorted array. So I have used one variable called maxseen so far, MSSF. It's basically abbreviation for maxseen so far. At each step, so we'll basically loop from index 0 to the end of index. Here it is 7, and we'll first calculate maxseen so far. It should be max of maxseen so far and array of I, that is the element value at that index in an array. And you can initialize maxseen so far as integer dot min value. So okay, so let's walk through one solution. So at index 0 over here, so maxseen so far equals max of maxseen so far, which is basically integer dot min value, array of I is 1, so maxseen so far will come as 1. Then we'll check if array of I, so if array of 0, that is 1, less than maxseen so far, less than 1, no, right? So we will not go inside and we will not update any right index because we know this is a right property of this array. We move ahead to the index 1, and then again we update maxseen so far is equal to max of maxseen so far. So basically it was 1 from previous step, and array of I is equal to 10, so now it will become as 10. And again we'll check if array of I, so basically 10 is less than maxseen so far 10, no, so again it's all right. So we will again move ahead and we will come to the position this one. So maxseen so far will be max of maxseen so far, basically 10 comma array of I is 9, so it will remain as 10 as per the previous step. And then we'll check if array of I, basically 9, is less than maxseen so far is 10. Yes, it is less than 10, so we'll go inside this if condition and we'll update the right pointer equals I. So in this case it is the index of 9, which is basically 2, because here we can clearly see also that 9 should, it's not the right position for 9. Then we'll move ahead to this index, and again maxseen so far will be max of maxseen so far and array of I, so it will again come as, it will remain 10. Again we'll check condition if array of I is less than maxseen so far. Now array of I is 3 and maxseen so far is 10, so it is, yeah, 3 is less than 10. Again we'll update the right index to the current index, which is basically 3. I'll just, you can just calculate it again. So you will reach at this position, and again it is out of order. We'll go inside this condition, right will be 4. We'll come here, max in so far is still 10 and we are at the value 5, so 5 is less than 10, so again we'll update the right as 5. Same way we'll come here, right will be updated as 6, and we'll come here, right will be updated as 7. So final right will be 7 and we are out of this loop. Okay, so here I have created a small table so that you can understand this logic in detail. So at the top row I have index which is 0 through 7, and this is basically array elements 1, 10, 9, 3, 0, 4, 5 and 8. And first step we are updating max in so far, so this value contains the max in so far. So initially max in so far can be initialized at integer dot min value. So at this position max in so far is 1, here it is 10, then you can see it is always 10 because it's basically the highest value. Okay, so it should always be also 10 over here. Then we are checking the condition if array of I less than max in so far. So here 1 is less than 1, no, right? So we will not do anything. If 10 is less than 10, no, so we will not do anything. And here yes, so array of I basically 9 is less than 10, so we'll update our right index as 2, so index of 9 elements. Same way over here, array of I 3 is less than 10, yes, so we'll update the right index as index of this position, so 3. At this position 0 is less than 10, again update the right with the current index, continue with this process, so the right will become as 7, so our final right index would be 7. Okay, now let's see the second part where we need to find the left index, and let me go through here, and we will loop from end of the array for finding the left index. And here I have again the same array, and at the top you can see the index. And what we do at the first step, we do a min so far, min seen so far is equal to min of min seen so far of and array of I, and you can initialize min sin so far as integer dot max value. So in this position we will find min sin so far as 8. We'll check if array of I, so array of I is 8, is array of I 8 is greater than min sin so far. So is 8 greater than 8? No, so we will not update any left index over here. We'll come here and again we'll calculate the min sin so far. So min sin so far will be the min of current value and the minimum so far. So again it will, the 5 is the minimum, and we'll check second step, is array of I is 5 is greater than 5? No, right? So we'll not update the left index. We'll come here and again we'll update the min sin so far. It will be basically minimum of min sin so far 5 and array of I 4, so it will become 4. Is min array of I 4 greater than min sin so far? So is 4 greater than 4? No, so we'll not update. Same way we'll come here, min sin so far will become now 0. Is 0 greater than 0? No. Now min sin so far is equal to array of minimum of current min sin so far, so basically 0, and array of I 3, so it will remain 0. Is array of I, so basically 3 greater than min sin so far? 3 greater than 0? Yes, 3 is greater than 0. So in this case we'll update our left pointer as the current index, which is basically 3. Okay, so here again we'll calculate at this index. So min sin so far is minimum of current value and the previous min sin so far, so it will become 0. And we'll again check the condition if array of I, so 9 is greater than min sin so far 0. So is 9 greater than 0? Yes. So we will update our left pointer as our current index, that is 2. We'll come here, we'll update the min sin so far of previous min and current value, so it will become 0 over here. And if array of I 10 greater than min sin so far 0, so yes, 10 is greater than 0, we will again update our left pointer as 1. We'll keep on for this last index. So min sin so far is minimum of current min sin so far 0 and current value 1, so it is again 0. And is array of I, so 1 is greater than min sin so far 0, so 1 is greater than 0, so we'll update our left pointer as our current index 0, and we are done. So basically we have reached till 0th index, so our left pointer will become 0. Okay friends, so while running through all this algorithm, we have found that right pointer is 7 and left pointer is 0, and we are finding right pointer while moving from left to right. So last updated value at right pointer is the final answer for right index. And same way for getting left index, we are going from right to left. So last updated value of left index is our final left index answer. So in this case, for this question, the answer would be 0 to 7. This seems to be a funny example because here we need to sort complete array to make this array sorted. So I have created one more example over here. You can go through in your own time. So the array is 1 2 9 4 3 7 8 19, and same way I have calculated max sin so far and min sin so far. So here the answer is like the left index is 2 and right index is 7. So I think with these examples and all the walkthrough of complete algorithm, we are ready to go through the code. So let's see the code. Okay, so I forgot to tell you about the time and space complexity of the second approach. So because we are moving array, sorry, we are looping through array from left to right to find our right index once, and again we are looping from right to left to find our left index. So basically we are looping through complete array two times. So order of n plus order of n. So the time complexity is order of n, and space complexity is order of 1 because anyway we are not using any temporary variable. Yeah, provided we are not counting the resultant values. Okay, so here I have taken one example. I am declaring one array and then I am running this function two times to get smallest window to be sorted. And first one is like brute force algorithm where we were sorting the array, then comparing index by index to find out which value is out of order. So there the time complexity was order of n log n because we were sorting the array first to that comparison, and space complexity was order of n because we were anyway storing the array again in a complete sorted manner. So let's see the first brute force algorithm. So we take a resultant array and we initialize this as an empty array list. We take left index as -1, right index as -1, and we again create a sorted array. Array dot clone, it's a function where it will create another array with the name sorted array, and it will copy the values of arrays into this one. So basically sorted array will contain currently the copy of the current array, and then we will use a arrays function which is our arrays dot sort. It will basically sort the sorted order array, and now it will become sorted. Then we'll loop through both arrays and find mismatched elements. So we are looping through I is equal to 0, I less than array dot length. Both of arrays, because they are same, they will have the same length. If array of I is not equal to sorted array, then and left index is equal to -1, then we are doing left index is equal to I. So why we are checking this condition? Because we have to find left and right index. So left index will be the first mismatched index. So we will stop counting left index once we are done with it. So in first scenario, as soon as we find the mismatch and left index is equal to -1, we'll update the left index and will not update left index again. But in the case of right index, you need to keep on going right until you find the last unmatched or mismatched value. So that's where we are not having any condition in else. So we'll just have array of I not equal to sorted array, and we'll update right index of I. So right index of I will be updated many number of times based on the question or or the array. Yeah, so basically it will contain the last mismatched index. Then again we know, like because it's a list, we can use list dot add. We'll add left index, right index, and we'll return the result over here. So this one was first brute force algorithm where we sort the array and then we do the comparison to find the left and right index. Okay, second is the optimized one where it will run in order of n time and order of 1 space. And let's go through the code. So here again same thing, we are declaring a result and resultant array. Then we have left index and right index initialized as -1, and we are using max sin so far, so we will initialize it as integer dot min value, and min sin so far will initialize this as a integer dot max value. Then again we will scan from left and find an index where value is less than max sin so far, so we will go from left to right. We will calculate max sin so far, which will be the maximum of current max sin so far and the value at current index I. So basically max sin so far comma array of I will take the max of it and will pass it to max sin so far. If array of I, if the current value is less than max sin so far, so we know that this is not correct, so we'll update the right index is equal to I, and we'll keep on doing this till the end of array, and the final right index value will be our right index. Same way, for finding the left index, we'll loop from end of the array to the index 0, and we'll have min sin so far. Min sin so far will be the minimum of the current min sin so far and the current value in the array, and we'll again check if array of I is greater than min sin so far. So it means that this is not the right condition, so we have to update the left index is equal to I. We'll keep on doing this as we already saw in the example, and it will keep on updating left index in case the array is not in proper order. Finally, we will add the left index and right index to the result list, and we'll return the result. So that's it, friends. So we have seen two algorithms to solve this problem. It's a pretty interesting problem, and yeah, we can run this one. So let me just go ahead and run this one, and you'll see the answer is 2,6 2,6 from both of the option. So that's it, friends. Let me know what do you think about this. Like or comment the video in case you want me to know how this problem how I have solved it. Do you like it? Do you don't like it? You can just let me know everything, whatever you basically think of, and please don't forget to subscribe so that I will be motivated to keep on creating these videos. Thanks again. Bye.